we used to do dishes without pee-pee.
I'm Kasia, and today I'm doing dishes just to check the streaming. And why are we doing dishes? We're doing dishes to remove all the grease and fat from plates. And to do that, we use detergent. And detergents usually break the structures of the fat. They make the water to easily grip on grease and remove that from our plates. The same thing do soap with our bodies when we want to remove dirt and oils from your body. But a long time ago, people have problems with using soap. As you probably heard, people's were smelly. And it wasn't because they were lazy, it was because it was hard to get soap and it was expensive. And it wasn't until 18th century when a guy who was called Nicolas Leblanc found the easier way to make soap. And soap started getting cheaper. You can think why grease is so hard to remove. It's because of its structure. Fat is made out of lipids. You can imagine them as a little sticks with head that likes water, and we call it hydrophilic head of lipids, and tail that doesn't like water, and we call it hydrophobic tail, or sometimes tails. So lipids create structures by binding together, where the heads line up together and the tails line up together. Heads towards water and the tails far away from water. They can create surfaces and then they cover surfaces, and when you have tight surface of lipid layers, it's hard to get under surface. Sometimes they create bubbles, and then around on the outer surface of the bubble you have heads, and inside of the bubbles you have tails. Sometimes structures like that can close things inside. That's what happens in our bodies. All membranes in human body, and in fact all organs, are made out of lipids. Most of the time they create lipid bilayer, where both sides of bilayer are created by lipid heads, and inside we have lipid tails. A lot of protein is incorporated into that bilayer, and they are held by bilayer, and they can perform their function. But also lipid bilayers have function. They protect us, they divide the different environments in cell. And as I said earlier, sometimes they can close things inside of their bubbles. And this kind of bubbles can travel around in your body just to transport substances from one cell to another or somewhere inside of the one cell. And sometimes they just float around having some things that we don't need in our body. Sometimes they are later eaten by macrophages when they have something that we really don't need. Sometimes they just are released by our body, and you can find them in your poop. But you can think if lipid bilayers are so hard to break and nothing can pass through it, well, you know that in organism, some information and ions and vitamins and other substances has to pass through bilayers. Well, the nature find way and created something that is called ion channels. Ion channels let pass different substances through bilayer. How they act also let establish balance between both sides of the membrane, which is called homeostasis. That's why our cells won't rupture when they accommodate too much things inside of them. Ion channels also allow to pass ions. Well, each substance in our world has electric charge. And electric charge is a way of passing information in organisms. So ion channels allow to pass some ions, and for some of them they are closed. Some ion channels allow to pass only negative charges, some of them allow to pass only positive charges. Some allow to pass only small ions like potassium or chloride. Some allow to pass much bigger substances like ATP. ATP is that substance that carries energy in our cells. For our bodies to work properly, all elements have to work properly. So our lipid bilayers have to protect cells, and ion channels have to control homeostasis, so to prevent our cells to explode, which is not good for cells. But sometimes it happens that ion channels don't work properly, and that disrupts everything. Some of the diseases that you might hear of are due to not functioning of certain type of ion channels. For example, mucoviscidosis is a disease in which chloride ion channels don't work properly, and that accumulates mucus on the lungs lining and make it difficult for people to breathe. During strokes, potassium channels have problem with working, and when ions can flow easily through a membrane, cells are dying. And when cells are dying, the tissues that is made of those cells is dying too. In most of the cases, we don't know why things get broken in our body. That's why a bunch of scientists sits in labs and tries to measure and tries to check what's wrong and how to fix it. But, cells are small. The structures inside of the cells are even smaller, So you can imagine that ion channels and lipid membranes are even smaller. So how you measure something that is so small? Well, people invented something to measure currents that can flow through the membranes. Do you remember when I said that ion channels allow to pass ions through the membrane? Well, ions create different charges. The movement of the charge is nothing else like electric current, but electric current. So we can measure electric current. But it's not big electric current. We're talking about passing few ions through a small ion channel. So the values of that current are measured in picoamps or nanoamps. To measure current so small, we need to amplify it to even see it. But still, to measure current, you need electrodes. And you have to choose where to measure your current. When there's a lot of things inside of the cells, and you put one electrode inside of cells, you will measure currents from everything that is inside of that cell. To make it easier, people use small glass capillaries. When they attach a glass capillar to a lipid bilayer, they can choose only small area of the surface from where they can measure a current, a small patch. The technique that allows you to measure currents is called patch clamp, because you're clamping small patches of the cell and measure current in them. Inside of that glass capillar, we have solution, because you know everything in our bodies is wet, and the water allows ions to flow inside. They have to flow in something. So inside of the glass capillar, we have solution that is very similar to the solution in our cells, and we have electrodes. When ions that pass through ion channel hit that electrode, they change the value that we measure in our equipment, and then we can tell how the current is flowing inside of our cells. We know how healthy cells look like. We always try to check everything on healthy cells at first, just to have a baseline for everything. So when we know how healthy ion channels in healthy cells look like, then we know when something is wrong with the cell and their currents are not looking well. Then we can try to figure out what changed that currents and what we can do to bring them back to normal. But on cell surface, we have a lot of small ion channels. How you can be sure that the channel that you cut inside of your capillar is the one that you want to check? Well, we know that some substances can block the channels, and they can block only one type of channel, and some substances can activate the channel, and very often they can activate only one type of channel. So by trying and applying those substances to your channel, you can check what kind of channel you have